Alright guys, so in this video we're going to be solving quadratic equations by graphing. Yay, we've been doing this all week, graphing quadratic. So now we're going to solve quadratic equations using graphing. The zeros of a function. When the graph of f of x intersects with the x-axis, or when f of x equals 0, think the x-intercept. That is called the zero of the function. If you look at the graph over here, wherever it crosses the x-axis, those are called the zeros of the function. The value of x at this point is when y or f of x is equal to 0. Think what is x when y is 0. Those are the zeros of the function. How do I find the zeros of a quadratic function? Below the graph of the quadratic function is given. So now I'm just going to have you guys figure out where are the zeros. What are the zeros? One method we can do solving by quadratic equations is by graphing. We're going to learn more throughout the week. But for this graph, using graphing, what are the zeros of the function? Well, x crosses at, when y equals 0, on the x-axis, it crosses at 5 and at -1. So the solution to y equals x squared minus 4x minus 5, the zeros of the function for that equation is x equals -1 and x equals 5. How do I write my answer? I can write it two ways. I can write it as a set, or you can write it as x equals a number or x equals another number like I did in the last slide. So the answers were -1 and 5. So I can write it. Remember to use brackets and not parentheses, because if you use parentheses, then that's talking about a point. And we're not talking about points here. We're talking about solutions of the equation. And then in the last slide, I did x equals -1 or x equals 5. So you can write it one of these ways, either this way or this way. Remember, if you use the brackets, to not use parentheses. So let's find the zeros for the functions of these. Well, this is my x-axis, this is my y-axis. The zeros of the function for this pink function over here, this pink graph, is when it crosses the x-axis, so when x equals 0 or when x equals -2. I can also write that as -2, 0. Sorry, I changed colors on you. All right. Over here for this blue function, this blue quadratic, again, this is the x-axis, this is the y-axis, where it crosses the x-axis. That is my solution, or whenever y equals 0. If you look at this point, this is where y equals 0, so what's our x value? X equals -3. Over here we have two solutions. It crosses the graph twice, y equals 0 twice, for this graph. But on this side, for the right graph, we have the quadratic only hitting once. So there's only one solution. For this last quadratic, x when y equals x squared plus 4, I have the x-axis down here and the y-axis. And when does it ever cross the x-axis? Will it ever cross the x-axis? No. For the range of this function is when y is greater than or equal to 4. So whenever y is at 4 or more, that's all my y values. So will y ever be 0? No. So do I have any solutions for this quadratic function, for this quadratic equations? No, there's no real solution. We talked about last week how there's imaginary numbers. Well, for this graph, there are imaginary solutions. There's no real solutions, though. So for this, whenever it does not cross the x-axis, we have no real solutions. So let's actually graph these quadratics. I have my little Santa Claus over here. I thought it was pretty funny. I thought I added in there. Anyway, first things first, graphing these quadratics. Negative b over 2a. b is negative 6. So when I plug in negative 6, I get a positive 6 over 2 times a. A is 1. 6 divided by 2 is 3. When I plug 3 back in, I get 3 squared minus 6 times 3 plus 8. 3 squared is 9 minus 18 plus 8. That gives me negative 9 plus 8, or negative 1. That I just found my vertex. So 3, negative 1 is my vertex. Remember to label your x and y axis. Now what do I do? 0, C is my y-intercept, so I can go ahead and plot that. I'm going to go 1, 2, 3, 4, 5, 6, 7, 8. It's a little bit off the graph, but I'm going to use it. It's not too far away. Remember, the axis of symmetry goes right through the vertex. And I'm going to have 1, 2, 3 away, 1, 2, 3. My other point, I know it's off my graph. Sorry. This is 0, 8. And this is 6, 8. My point, my vertex is 3, negative 1. And I need 2 more points still, so I'm going to plug in a number. I already plugged in 3, and I have 0, and I have 6. So I can pick a number between 0 and 3 and 3 and 6. I'm going to go ahead and go with 1 because 1's easy to plug in. So 1 squared minus 6 times 1 plus 8. 1 minus 6 plus 8 gives me 3. So 1, 3. And then I'm going to reflect that point. And draw the graph. Where does it cross the x-axis? Right here. When x is equal to 2, y will be 0. And when x is equal to 3, 4. So the solutions, or the zeros for this function, are, let me write it in a different color so it stands out, 2, 4. All right, so this was a pretty short lesson. We already know how to graph quadratics, so be prepared on Monday to graph some more quadratics. Try these 2 problems. Remember to graph them on graph paper, and find the zeros of the functions. I want you to find the zeros. So graph, and then tell me where it crosses the x-axis. Hope you have a great weekend.